All right. Well, welcome to Intro to Data Analytics. I am Dr. Marcello, and it is awesome to see you folks in the classroom. This is so exciting, a full house. How cool is that? I'm so glad you came out. And I'm wondering, from a show of hands, how many of you took a little bit of Python during the Tech Foundations course? Anybody? A couple of people? All right, so that's good. I'm glad you got some exposure to Python. Tonight's class assumes no exposure, okay? We're going to start from scratch. We're going to explain things. So if you're nervous at all, don't worry about that. We're going to kind of get our feet wet and get our, confidence into the material. And then each week we'll go a little bit higher in depth, right? So no worries. We will be doing some typing tonight. And I do understand that some folks type faster than others. So no worries. The goal is to be able to follow the material. Now, one quick question I do have is on OpenHub. Under the class, there's a bunch of resources that I shared. I'm going to go ahead and share my screen and share those resources just so you can see the screen here. Okay, so under class 1, basically, and you all should have access to this. If for some reason you don't, just ask someone to help you get access to this. But there's a handout that I posted, which is a PDF. We're going to be going over that first. And then there's some resources, links basically that you will be utilizing during the class tonight and also for homework. Okay, so the ones that are marked homework, you're basically going to create a Google account. That's one of your homeworks. And then you're going to click the link for Introduction to Google Colab and read some of the material. It's basically 1 or 2 pages that you're going to be reading. The third thing I wanted to show you is there's a link to a document. It's actually a book, and it's called Think Like a Computer Scientist. It is an awesome reference book. It's like 250 pages. You're not expected to read it all at once, right? But it's great to have on your computer. I would challenge you to read a little bit each day if you can. Highlight, maybe print it out and highlight so it makes sense to you, okay? It's one of the great, we'll call it open educational resources. It doesn't cost any money. You can buy the Amazon version if you want, and it's not very expensive, but honestly, I just like the PDF because it works, right? So I can read it on my phone and such. So I highly recommend that you do download that. And then each week, when we have class, there's a Zoom link to the live class. So if for some reason 1 week you're not attending at the library, which we highly encourage you do, but let's say you can't, this link is to the live class. After our class, remember I'm recording, I will post a link to the recording underneath this link here. So let's say you go home and you decide, I want to look at the lecture, I want to see what we did, I want to review. There'll be a link under here once the recording is done and processed. So I will make sure each week we have the same link for the live class, and the recording is posted so you can get to it each week. All right, so that's something I just wanted to show you, and hopefully you all have an account and you have access, all right, to that material. All right, how are we doing? It looks like we have more than a full house here. This is wonderful. This is wonderful, wonderful, wonderful. How cool is that? All right, so Julia, are we ready to get started with the PowerPoint really quick?
Yes, we are, and we need actually very big fonts because full class, it's hard to see.
Yes. Okay, so when I share it, I'm going to zoom in. Now, one thing to remember, Julia, and I don't know how the library is set up, but on the Zoom screen, can you zoom in on that end? Because this way you can control it. That's something to maybe look at. Let me go ahead and share.
We might be able to zoom in. We might be able to zoom in.
Okay. I'm going to go ahead and go into the actual presentation, and you can see class 1's really tiny. I would zoom in if you can to make it bigger, and if you can't, let me know and I'll try to do it on my end.
Good afternoon, laptops are coming. Dr. Cynthia, can you
Yes,
stop recording for a minute and
I
tell you
sure can. Absolutely. Hold on 1 minute.
we
I
need to
will.
rearrange
No
more
worries.
tables and more laptops.
Okay. So we're almost ready to get started. Can everyone hear me okay? Is my voice carrying to the back of the room? Awesome. Oh, good, good, good. All right, wonderful. So Yulia, once you're ready, I will start the presentation. Just let me know.
I'm ready.
Okay, we are ready. Okay, I'm going to go ahead and share my presentation. Now, this is very short, but it has some really important information. There's a reason why I'm sharing it, because it has all the facts that we need. And I'm sure all of you are wondering, what is this about, right? What is this about? So let me go back and share here. There we go. All right. So I'm going to go ahead and go into slideshow view here.
Recording.
Is it working okay?
Record.
I am recording.
Not yet. Yeah.
You want me to stop sharing and check again? I did turn it on.
No, it's recording now. Okay.
I have only a pause button and a stop button. I've started it. So are you seeing something different on your end?
We're good. We're good.
Okay, I'll share again. All right, where was I? Okay, can everyone see a very simple screen here? Whoops, let me jump back here. And it's looking a little strange. Hold 1 second here. What is that about? It's sharing half the screen. So let me go back here. All right. Okay. Class 1, very simple, very simple. Okay. Intro to data analytics. So this is class 1. Let's go ahead and get into the material very quickly. What I want to explain, and I apologize, my mouse is being a little bad at the moment.
Share your own view. So
Excuse me?
You're sharing your own view of the slide deck. So it means we see the next coming slide and we see your management.
Okay, hold on.
Slides are too small.
I stopped sharing.
Okay.
I stopped sharing. I'm clicking as fast as I can. I am sharing it. Let me go ahead, and if you would give me a minute to get the presentation up, because I was in the middle of sharing and then I stopped, and so it's in a funk here. Okay, let me add Walker. Let Walker in. Okay. All right, hold on 1 minute. It seems the sharing is being a little troublesome. Give me 1 second here. All right. Here we go. Technology can be very special at times, right? All right, now I'm going to start the presentation. All right. Do you see the right screen?
Yeah.
Yes.
Yay. All right. So in the intro to data analytics info session, right, we talked about the necessity to analyze data. And so you're applying logic to the process of processing the data that you want to analyze, right? So you're taking that data in as input, and that then determines the resulting output. So if you make a mistake in the logic, that will have implications on your ability to gain insight from your data. So the data story that we talked about last time doesn't get told correctly. It has flaws in it. And so what ultimately happens is you can't use the result as a way of gaining insight into your problem, whatever the problem is. So understanding how to use Python or any programming language for the purpose of data analytics is essential. So tonight we're focusing on the control structures that we typically apply to the logic that we build as programmers or data scientists. So control structures, as you may have guessed it, control the logic. It controls how the program works, okay? So let's talk a little bit about how that applies to Python. Well, Python uses three classic control structures: the sequence, the selection, and the repetition control structure. Now, what does that mean? Well, let's look at it. Sequence is basically a set of statements that get executed one by one. Tonight, we're actually going to be building all of these different types, all these different flavors. And what I encourage you to do is remember what we talk about here and say, okay, now I'm getting it. So as we start working on the code itself, I'll remind you, this is one of those. This is a sequence structure, or this is a selection structure. A selection structure is an if-then statement. It basically uses conditions to determine what the next step is going to be, right? And then of course, repetition is loops. Repetition is, I have a task I need to do, and I want to repeat that task over and over again. And so it's the same task, but it gets done over and over again. This is the classic IPO, or input, processing, and output. So input comes in. It may come from the user typing in something. It may come in from the machine or the computer, right? Which we're going to do in future data analytics classes. And once that information comes in, the algorithm applies computational procedure. It says, okay, I'm going to process this data based on whether it's a sequence, a selection, or repetition, and then show the output on the screen. It could be a message, it could be a list of information, and perhaps you want that output formatted a specific way so you can read it appropriately. So this is the classic everything. One thing I want to stress, and I stress this with all my college students, this is what has the value: the input, the algorithm, and the output. So if you understand these principles, you could apply it to any programming language. Okay, so we're going to spend a lot of time on this because it is essential. This is where the value is. This is why Google and Elon Musk and all those folks in AI, they are very famous because they've written algorithms, and those algorithms do things that make businesses more effective and more efficient, and so on. All right. Now, IPO is what I mentioned earlier. Very simply, input comes from the program. It comes into the program rather, and it's either by the user or the system. Processing occurs on that input, and then of course output occurs as the result. So the results of whatever processing I coded in, that's what's going to happen as a result. So let's talk about sequence statements. We'll kind of break them down. So a sequence statement is just a set of statements. It could be one statement, which is kind of boring. It's like, oh, a sequence of one thing, yay. Or it's basically a set of steps, right? So there's usually more than one statement. So one thing to remember is if your logic breaks, like if there's an error in your logic, then the whole program will fail, because a sequence requires that all of it be good. So everything in that sequence has to be good, or else the program breaks. So it's either good or bad. And from a binary perspective, it's 1 or 0, it's on or off, it's yes or no, right? So the steps are basically do this, do that, and do something else, right? Very simple. It's a series of steps, and notice they're ordered in order, right? So I don't expect to do step 2 before step 1, because as we all know, step 1 comes before step 2. So that's the logical expectation, right? So for example, if you wanted something to output to the screen, and let's say you wanted it to happen last, you wouldn't put it as step 1, because something else would get executed as step 1, and that's not the desired result. Okay, so selection statements are a little bit different. These are conditionals, or if-then statements. And so what happens is a condition is tested, and it's using a Boolean expression. And don't let the word fool you or scare you. There's a guy named George Boole back in the day who was into math, and that's why it's a Boolean expression. So the guy's, famous, okay, George Boole. Because of George Boole, we have these Boolean expressions and they render true or false. So if you ask a question, for example, let's say I ask a question, is today payday, right? It can only be yes or no, unless you get paid every day, and then it's always yes, right? But none of us get paid every day, right? So if you think of it this way, is the sky blue, right? That's a Boolean expression because it can either be yes or no. So what happens is you test that Boolean expression, and based on the result, true or false, your code will execute, accordingly based on how you've designed it. Now, there's 4 basic flavors of if statements or selection statements in Python. There's the if else, the nested if, and the if elif else. I know it's strange, but we're actually going to code them. So you're going to have separate examples of each one. And I'm going to show you how to use comments in your code so that you can go back to your code after class and say, I know what this is because I put a documentation in there. I commented it. All right. So we're actually going to go over all of these statements tonight and build them ourselves. The last is something to remember is, and let me just jump back. We talked about what a selection statement is, but we can describe it graphically. The last thing I want to, help you remember is that some of us are more visual and we like flowcharts, right? And some of us might write pseudocode, which is a description of the code, and they mean the same thing, right? So for some folks, the flowchart of an if statement makes more sense. So when I start the program, notice the arrow coming down, I then am hit with a condition that I have to test. And if it's true, the arrow goes one way, and if it's false, the arrow goes another way, right? Notice that if it's false, no code gets executed. Only when it's true. Notice there's conditional code under the true, and that means your code will only execute if it's true. So if your program doesn't work the way it's supposed to, and you've created an if statement and it doesn't give you, the conditional code doesn't run, you know that you're not testing your Boolean expression properly, okay? And again, this might seem like a lot, but if you do the data analytics class, the intro from start to finish, and later on you get into the data analytics bootcamp, you will see this over and over again, and it'll make perfect sense. All right. Another way of looking at the if else statement is to look at a flowchart. Again, some of us are more visual in our learning, right? We kind of look at things differently. Now, the Boolean expression is always in a diamond. You see how this is a diamond here? The if condition. The condition is always placed in a diamond. So the symbols in the flowchart are really important. So whenever you're describing that Boolean, it's always a diamond. All right. And again, if something is true, then go to the if body and execute it. If it's false, go to the else body. So you always test for truth first. Once you know the results of that, right, you know it's either going to execute the true or the false, but it will execute one or the other. Why? Because those are the only alternatives that you've given, right? It's either true or false. It can't be halfway. Thank God for George Boole, right? Because if something was half true or half false, oh my goodness, right? That would be kind of strange and very weird. Can you imagine them saying, well, I think you might get paid, it's halfway true. Well, what does that mean, right? What does that mean if halfway true, right? Not making sense. All right, now we get to one that's a little more complex. It's a nested if. Again, we're going to do all these in code. So now we have 2 questions, 2 Boolean expressions that we test. If condition 1 is true, then we ask about condition 2. So we actually asked 2 conditions. So you might say, is today a payday? If yes, then does my employer have my direct deposit information? That might be a second question that you're testing. And if that's true, you'll get direct deposit. If it's false, you get a regular paper check, right? Can you kind of see that? So is today payday? If true, then ask the question, is direct deposit set up? If true, then direct deposit happens, right? If it's false, you get a paper check. And that's just so you still get paid. It's just your method of getting paid is different. Okay. Now, if today is not payday, we don't have to worry about direct deposit We don't have to worry about checks because it's not payday. So if it's false, then we go to the else. And that's a really simple way of understanding it. All right, now we have the if, elif, else statement. So this is kind of interesting in that it asks the question differently. There's still two conditions, but the second condition is based on a false outcome. All right, so let's use that same example about payday before, right? So if today, is today payday? If no, then ask the question, have you set up your direct deposit with HR? If no, if false, then you go to here, get to HR and set that up, right? If it's been set up, say you'll receive your first direct deposit on Friday, okay? So you see how that it asks that second condition, that second question, it tests that Boolean expression on the false and not the true. Whereas in our prior example, it was on the true, okay? Now, keep in mind, this PowerPoint is on OpenHub in the classroom, so you can download it, put it in your notebook, bring it to office hours if you get stuck. This is a great resource for you, all right? All right, so let's talk about the last control structure because we want to get into coding, I'm sure. Repetition statements. Now, these are also known as loops, all right, if you've heard that term. Python uses two types of loops. One is a for loop and one is a while loop. A for loop basically counts the number of times it needs to do something, right? So let's say I have to do a particular task more than one time, right? And I know it's only 3 times. Well, that for loop is going to process 3 times because I told it only do this 3 times. So it's a counted loop. I give it a count and it says, okay, I'll repeat the task 3 times. Okay. A while loop repeats the task while something is true. Another conditional, right? So the conditional determines whether or not the loop keeps working. And so once it's done, once it becomes false, the loop stops. And when you see some examples we're going to do tonight, everything's going to, gel with you. And if anyone's confused, do not worry. You're going to see it in action. All right. So to summarize, and again, this is a very essential but very quick way of looking at the 3 control structures. Keep in mind that these are applicable for all programming languages. They determine how the logic flows in your program. Without them, your program has a mind of its own, and good Lord, we don't know what it's doing. And if we don't know what our program's doing, we better run, okay? Because it's automatic and it's doing its own thing. So we want to control the logic, and the way we do it is using a sequence, selection, repetition, combination. So our program is going to have combinations of all of these based on how we intend our program to function. So the algorithm describes the logic for the program. The algorithm is the value. You could be sitting in an airport and think of an idea of an algorithm, write it down, put it in your luggage, and that is right now very valuable because it's describing your thought process for logic. So whatever you do, think of the algorithm as being sort of the skeleton of your program, and that is what the value is, okay? When 2 companies buy each other out, let's say one tech company buys another one out, it's because of their algorithms, right? So that's just something to think about. I've seen people sketch algorithms on paper napkins in like a restaurant. We've had working clubs where we go to a restaurant and we jot stuff down. So just remember, it's creative process. So any of you that are creative, that's something you want to think about. I can be creative and create algorithms that do really cool things. All right. All right. So I'm going to stop sharing that screen. Anybody totally bamboozled? Questions? Not sure? Yes, no, maybe? Any quick questions? Everyone's good? Awesome. All right, everyone's good. That's what we want to hear. All right. So the next thing we're going to do is we're going to go into the link that I provided in the classroom. Now, if you don't have that link, I am going to post it in chat. I hope that works for everybody. And I can actually share it on my screen. Would that be easier?
Yeah.
Okay, hold on. I just realized, you know, given what you guys are doing. So hold on 1 second here. And I want to make sure it's big enough for you guys to see it. Good old notepad. Can everyone see that? Hopefully everyone can see. And I can make it a little bigger. I just don't want it to wrap around. Oops. Once you have that typed in and you're at the screen and everybody's ready, then I'll stop sharing this and share my screen with you. Ah, okay, hold on 1 second here. Okay. Let me know when everyone's ready and they're at that page. Okay. Anybody not there? Can I take this down all right?
No, not yet.
Okay, all right. By the way, where you're going, and I'll just chat while you're doing that, this is called an online compiler. Now, why do we like these kind of things? Well, because you can open up this online compiler anywhere that you have internet access. So it doesn't require you to install things on your computer. And so it's one way of executing code. It's a great way to practice your skills. Okay, so this is something you could launch in the library and during office hours and practice. So that's why we're using this online compiler.
Do you need help? Everyone's We need everyone just to get to this page. You need to raise your hand if you're done. Everyone is done?
Everyone good?
Yeah.
Yay, all right. Everyone's good, right?
Yes, they're quietly good.
Yes, yes. Okay, good, good, good. All right, so now I'm gonna share my screen again because I'm gonna show you my my online compiler. All right. Can everyone see this okay?
Yes.
There you go. You may need to
Everyone
zoom.
good?
You
Now,
may
when
need
you,
to- I'm
when
sorry,
you-
you may need to zoom in a little bit.
I'm sorry?
You may need to zoom in a little bit. I'm sorry, the browser. I don't think anyone can read.
Are you able, all right, can you please zoom in on your end?
Yes.
Yeah, I think that's gonna be more ideal. Give that a shot, and if that doesn't work, then I will zoom on my end. I'm gonna have limits with the browser, so I'm thinking it might be better on the Zoom side. Just let me know.
Go on the toolbar and you can zoom in.
This here?
Next to the green banner right there, drop it down. Next to the, says view options.
Yeah.
Now
Okay.
you can zoom.
Okay.
How does it look okay?
Okay.
Okay, so you'll notice that it says online Python 3 compiler, and it says what? Print hello world, right? So print is a function. Print is a command, okay? That command basically is telling the system to do something. So is that output, do you think, or is it input, or is it processing? What do you think? What's that? Input?
Yeah.
All right, there's some input. Where's the input? I like that. Where's the input part?
The green color. The green one.
The green color. Excellent, excellent. So that's a literal message that we gave it, right? The print command then takes that message and then does what with it? It outputs it. So let's test that theory. If we click execute on the right-hand side, what do we get on the right-hand side? Output. Oh my gosh, I'm gonna have to move faster. You guys are really rocking and rolling here. I love it. I love it. So here we have input, processing, and output. So the processing is which part?
The print.
The print. Oh my gosh. Excellent, excellent. So print is a command, and that's our processing. So that's something to remember. It could be a very simple command, and you have input, processing, and output. All right, we're going to delete that out, the print hello world. All right, and I want you to just look at the comment above. Now it's in purple, and there's a hashtag in front of it. That's how you create a comment. A comment is not compiled. That's how you document your code. So what we're going to do, very first thing, is we are going to create a comment, and we are going to call this example 1. And it's going to be a sequence statement. Okay. And this tells us that we're about to create a sequence statement. So when you go back and you look at your code, you'll be able to refer to that. Okay. Now, everyone's good? I don't want to go too fast. So this is going to be a sequence statement. I want 3 things to happen. I want to print hello. We saw that before, right? I want to print hello. On the next line, I want to print, print, and I want to say my name is, and you want to put your name, okay? And then I'm going to print, whoops, no typos, not allowed. What is your name? Okay. So I've created a series of steps that will execute in a sequence. So based on what we learned earlier, hello should come out first, Then my name is your name, whatever it be. And then the next thing is, what is your name? So if we execute this, sure enough, it runs in a sequence, step by step, and things run in order. Okay. That should make sense to everyone, right? All right, let's look at another example. We're going to do example 2. Whoops. Helps if I hit the right key here. Example 2. And again, this is a sequence statement. Okay. And again, to show that there's different ways of doing a sequence, we're going to declare a variable. All right. Now, when you declare a variable, you want the name to make sense. So I'm actually going to declare a number. So I'm going to call it num1 equals, and I'm going to use 100. Why not? Right? So what I'm saying is assign 100 to the variable num1. That's the name of my variable. Num2 is equal to, well, let's go with 35. Why not? Notice we are providing the input in a hard-coded style, very much like hard-coding a web page, right? So we've said num1 is going to be equal to this, num2 is going to be equal to that. Now we're going to say assign to the variable name result equals to num1 plus num2. Okay. Everyone see that and everyone caught up?
No.
Okay, all right, I'll wait for you. And while you're typing, I'm going to just reiterate, and I can add a space here if that makes it easier to see. All right. We're assigning the value of num1 plus num2 to the variable result. It's called result.
So spaces doesn't matter.
The spaces do not matter. They're just for aesthetics. Yep. It just makes it easier to see. Now, in some cases, spaces will matter, but in this particular case, the way it is perceived programmatically by the compiler, it doesn't matter. Okay. So at this point, if we run this, we don't see a result, do we? Who knows why? I think I heard you.
You have to print the result. So you do print.
Boom. There you go. All right. So we're going to use our print command. We didn't tell it to do output, right? We're going to use our print command, but I'm going to show you a nice trick. We're going to type the result is colons. All right. That's the literal string. Okay. And after the quote, the double quote, we're going to put a comma. And now we're going to type num1 because that's the value we want to refer to. All right. Num1 is the variable. The value is stored in memory, right? Num1, comma, quote, dash quote, comma, num2, comma, a lot of commas action here, right? Literal equals, comma, result. So we're telling it we want output, but we want it to be very specific. We want it to say the result is 100 minus 35 equals the result. So we want to tell it exactly how we want that output to be. This is called concatenation. We concatenated variable names to literal strings. Literal strings is the result is all the stuff in green. All right. So now when I execute it, I get the result, which is based on my input, based on the processing, which would be the print command and also the subtraction. Notice you can subtract very easily, right?
Supposed to plus be plus, not minus, right?
Yes, yes. So I'm getting to that. That is correct. Someone picked up on it. So is everything okay with what we did? Is it logically correct?
Thank you. Thank you. Yeah, thank you.
Is it logically correct? Semantically, it's not correct, right? Logically, it's not correct. Syntactically, it ran, it compiled. We didn't get an error, but the program is not valid because it does not do what we intended it to do, right? So we have to look and see, what did we do wrong? Oh my goodness. We want to print the results, right? And we want to have plus. So we need to describe it better. All right, so I'm just going to change out the very simple boo-boo I made. It should be a plus sign, right? So logically, it didn't make sense based on my intent for the result. And that's a very easy mistake to make. Okay. Everyone good so far? So that's an example of a sequence, right? We have a sequence of statements that get executed. Let's look at a third example. All right. Now this sequence statement is another example. We are going to, and you're going to like this one. We're going to change how we get our input. Our input is going to come not from the computer, but from you, the person. All right. So in order to do that, we are going to prompt the user for what we want. Remember, if you're at a computer and you don't know what's expected, you're not going to be able to do anything. So we're going to print, all right, enter your name, please. Okay. And then on the next line, we need a command that allows us to get that input from the user. Now, we did a print function before. We're going to introduce you to the input function. So name is equal to input paren, which is a function that basically gives you the ability to type during your execution of your program. Okay. After that's done, we want to print the word hello. All right, literal string. And then we want to replace the second part of it with the name that the person typed. Okay. Another way of passing values into the print command. So now when we execute that, you will notice at the bottom of your terminal, there's a blinking cursor. So you're going to type your name, all right, and press enter, and it's then going to greet you. Hello and your name. Everyone good? Anyone have trouble?
I need a minute. Yeah.
Give us some minute.
Yeah.
Are we breathing okay here? Do we need more?
Oh.
No problem. I'll wait.
I'm sorry. I'm sorry. So let's see this now.
We need more air.
Anybody wants to see the other screen, just let me know.
Thank you, Jack.
Yeah, I have it zoomed in at 300%. That's the only way people in the back can see.
No, that's thank you so much, Jack. And that's definitely more doable on your end. So I appreciate that.
One question, can you slide the pane to the left?
The gallery, yeah,
Yes, I can
absolutely.
see the output better.
How's that?
The white, the white pane where you have your cursor. Yeah.
Okay, let me see. It looks
And
like
that's-
the advertisements, unfortunately, are it won't let me, Jack.
Okay, so you can't, like, right where terminal is, there's no, like, this window pane here.
Nope. Nope.
Okay.
It's an advertisement they want you to see. Is that what you're trying to do, Jack? Get rid of the advertisement?
No, above terminal where it says hello in your output. The
Yeah.
white border. the
Oh, you
white
want
border.
this way?
Yes, there you
Oh,
go.
I
Beautiful.
apologize. Absolutely.
No, that's all
I'm
right. Now
sorry.
we don't have to pan left or right anymore.
Yay. Okay, Jack, thank you.
And then, oh.
So you just have to click.
Thank you.
Maya, you want to take this spot?
Ryan.
I have the available for Ryan. Yeah. What is my name?
You just put in the terminal.
I was looking for my name. Who's my name?
You guys. There's a video, thank you.
Does anybody need help?
You good there, or you want to move forward?
Oh, I do.
Everybody can see well, right?
Everything there.
Oh, yeah. Right here.
But. Yes.
Our folks that are zoomed in, are you guys okay? Walker, Ormando, you okay?
Yeah,
Yeah?
so is it supposed to say, hi, Cindy?
Well, no, because there's no hi in the
Or-
code.
Because yours had said hello before, but then I guess it's not there currently?
No, it is actually. You don't see the terminal?
No, I do. I thought it had said something under enter your name, please.
Actually, there was a value. So I refreshed the terminal. All right. Whoops. And actually, I refreshed. I have to execute again. So let me do it again. And let me pull this over. Okay. So see where my cursor is? Right.
Oh, okay. So you entered something in the terminal. Okay.
Yes. Yes. Yeah. So when you ask for input from the user, it's going to get typed on the terminal side. You got it. Yep. And it's a very gray cursor that you'll see. Yeah. Yeah, I had refreshed my terminal. That's why you didn't see it. I hadn't typed it yet.
Okay, great.
Yep, yep. Good, good. I'm glad we fixed that for you.
There must be something wrong. Mine says bash Walker command not found.
Okay, so that means that you typed it probably like I just did before. So you want to make sure that when you execute it, the last thing that happens, it prompts. And so you're going to type it right here. So try executing it again. And then you're clicking right underneath and typing your name.
Okay, now it says hello, Walker.
Yep, yep, yeah.
Okay.
It probably just got it in a font, kind of like mine did.
Okay.
Yep, yep.
I think putting your name was more than
Hi, Stephen. Good to see you.
Oh, yeah.
Oh, so you know.
Bitter.
Yeah, and then the second meeting.
Yeah, I'm not sure my name.
So.
Type in.
Yeah.
Oh, on. Yeah, that's right.
There you go.
Wow, thank you. My God, so.
Yeah, hold on. Let me find one. Excuse me.
Yeah. We're thinking. Yeah, that's a lot. Yeah, we have much money to do.
Oh, it's a- maybe the boss now.
I just. Here. Thank you.
Are you getting it now?
Thank you.
Yes.
So it is, I just put my name in, and I can enter it. That was. I said, I'm said forever. Yeah.
There you go. Anybody else need help? Who needs help? Does anyone need help?
Everyone's
we're-
okay?
Yep.
All right, everyone's done? Yay. All right. So any questions on the code that we just typed? Anyone stuck on it? Do you not understand what we did? Now, keep in mind, I will be uploading these code samples to OpenHub under the class area because we're actually going to delete what we just did and add a different code in there. So don't worry about it if you're losing your code because I'll put them up on the OpenHub website under our class, okay? So basically what we just did, just to reiterate, is we did 3 different types of sequence statements running one task at a time. Notice each task is different. So it's not like a loop because it's not the same task. It's a different task, but it's in a sequence form. Okay. All right. So now what we're going to do is we're going to delete this code here, all of it. Everyone's like, no, I don't want to delete it, but don't worry. I will share it with you on the website. No worries. So now what we're going to do is we're going to put a comment in. Example 1, this is going to be a selection statement example. And again, this is the second control structure that we talked about earlier. All right. And if you remember, there are different types of selection statements. So we want to qualify or basically further explain the specific selection statement we're doing. So we're going to put another comment in that says this is a single alternative if statement, okay? Meaning that there's just one alternative. And again, we're doing this in Python. All right, so first things first, we are going to declare a variable called num, and we're going to assign 100 to it. So very simply, we declared a variable, we assign 100 to it. That's how we're providing the input. We're now going to test a condition, a single alternative if statement. So if num is greater than 75, so that is our condition, right? And we're basically asking the question, is it true that num is greater than 75, right? So that's our Boolean expression. We're basically testing that. If that's the case, print a message. All right, the number, whoops, don't get your finger now caught in there, is greater than 75. All right.
Hey, Cynthia,
Yes.
did you mention that when you do carriage return, it automatically indents?
Yes, I was just getting to that. Yes. So when you press enter after the colon, it will automatically indent. Now, let me explain why this is important. It automatically indents for you because it requires 4 spaces of indentation after that colon. All right. When you're typing in a variety of different IDEs or, softwares and what have you, you want to make sure that the formatting is accurate, and Python is very fussy. Okay, so this actually indented it for us, which is wonderful. So let's go ahead and execute this. And let's see if we get the result.
Can you slide the pane over again?
Absolutely. Thank you, Jack. We will be sliding regularly. Come on now. There we go. So is it true? Would you agree that the logic is correct and that the program runs as intended? That's a good day for a programmer. It's when it doesn't run as you expect or as you intend, and then you have to debug and figure out what's going on. Right now, our logic is rather simple. So we're not having to, launch rocket ships or anything like that yet, but we will be, I can promise you. All right, let's do another example. Let's do example 2. All right, and actually, while we're typing our comment, example 2, this will also be a selection statement. Is there anyone that does not understand why the prior one is a single alternative if? Does everyone see why that is a single? Alternative. There's no else, so there's only one possibility, right? Now that can get kind of strange because if it were false, we don't get a result, right? So let's do another one. All right, so let's do the same thing. We're going to do num equals 100. All right, if num is greater than 75. So if it's true, colon, notice when I press enter, what happens? It indents automatically. Thank you. We are going to print the number is greater than 75. Whoops, get the quote in there. Okay. Else, now notice when I press enter, it's still underneath print. I need to press backspace, put else, colon, print, the number is less than 75, right? That's the only other possibility, right? It can only be greater or less than. Is less than 75. And actually I fibbed just there. Is it true that it can only be greater than or less than 75? Who agrees with that statement?
Can be the same as 75?
Aha, excellent. Very smart. So the way we've set this up is if someone typed in, or if we assigned rather 75, there's no logic to support that. Okay. So a better way would be to do greater than or equal to 75. That basically allows for a 75 or something that's greater or something that is less, right? So at this point, we're going to take that equal sign out only because the logic that we're putting in here has only 2 possibilities, right? It's a dual alternative, okay? So let's go ahead and run that. And let me move this over. Jack, holler if you can't see it. Okay. So did everybody's program work properly? All right, we've got half yes, half no. That means there's true and false in the room. Oh my goodness.
You okay?
Everyone's getting there?
Thank you.
So, you're gonna be good, George, back to you.
My impact was, it went into it for some reason. And you're so, you're showing how to go back and shift to have a thing. And then, I got a single quotation.
Anybody else?
No.
Everybody else need help? Raise your hand if you need help. Going once.
Everyone's good?
Going twice. Take it away, Cynthia.
Woohoo! All right. So now we have a dual alternative if. And what does that mean? We have if something is true, do something else, do something else. That's a dual alternative. So two pathways. Now it is limiting in that we have not accounted for if it's equal to 75. But what we do want to do, and we'll entertain that in a minute, what we do want to do is that we want to change the value of num. So let's just change it, I don't know, to 25 for the second example here, the one that we're working on. And let's re-execute it. And sure enough, it tells us something different because 25 is less than, it gives us the second alternative, right? Not the first. So logically, this works properly based on how we've coded it. Again, we've recognized that it doesn't include 75, but that's okay. Let's say the purpose is not to include 75, right? Let's say 75 is not possible given the context by which we're writing this program, right? Let's say, given the scenario, it can only be less than or greater than, but not equal to. All right, so you want to think about it. It's not always the case that you want to support equal to, right? You have to think of the scenario. All right, let's look at another example. We're going to call this example 3. All right, example 3. This is going to be a selection statement. Oops. Work with me here. All right, statement. This one is going to be a different flavor. We've covered the single, the dual. We're going to do a nested if. Now, this is one of the most hard examples. Well, at least most people say nested ifs are a little bit tricky. So if you find this is tricky, don't worry about it. We're going to walk through it. Okay. And I'm actually going to delete what's above here so you guys can see this better. All right. Okay. So what we're going to do is declare 3 variables. Num1 is equal to 1500. Num2 is equal to 2500. And num3, num3 is equal to, I don't know, 1000. Why not? All right. So we've declared 3 variables. We've assigned 3 different values to them. Okay. So we've provided the input. We've basically hard coded the values into the program. So now we're going to write some logic. If num1 is greater than num2, again, always put a colon after that. We're going to, you guessed it, print, right? Print. Okay, we're going to print num1 value is biggest, okay? Num1 value is the biggest. All right, so that's the first part of it. That's a single alternative, right? So it's definitely not nested. Let's look at what would make it nested. All right, we're basically going to do an else statement. Now, an else statement we did earlier. This is going to be handled differently based on what we type on the next line, on line 12. So let's do else print, or I'm sorry, print the print statement, my bad, else print. And what's the other scenario? Well, num3 is the biggest, right? Num3 is the biggest. Now, does that make sense? What do you think? We referred to num2. Should it be num2 or num3? What do you think? Nobody knows, right? So we started our selection statement. We're attempting to do a nested if, right? But we have to know what we're doing as far as context goes. So typically when you compare numbers, you go num1 to num2, right? You say, well, let's look at the first one and the second one, see what the outcome of that is. And then based on that, work with number 3, right? That's typically how it's done. So what we're going to do is we're going to assume that because we've looked at num1 against num2, we're going to print num3 value is the biggest. And we're going to talk about why that would be a logical progression for us, okay? And this is, again, I warned you, this is where it gets a little tricky, okay? So far, so good. So let's think about logically, what have we just asked for? If num1 is greater than num2, right? That means that num1 probably is going to be a larger value than num2, but we don't know anything about num3, right? We don't know anything about num3. So can we safely say that num3 is the biggest value? Maybe, maybe not. And the reason we're doing this is we want to understand our logic. All right, next thing we're going to do is we're going to talk about how this is formatted. Notice how I did not wrap around the print statement. Notice one of them is indented, the other one isn't, and it's got the else next to it. That makes our code hard to read. Okay, so when you're coding, you want to make sure that it's readable. So if you share it with a fellow programmer, they're able to read it as well. So here's what I'm going to show you. You always want the print statement to be on the next line. Isn't that easier to read? A lot easier to read, right? They're not all jumbled together. So that's why we're doing that. Now, I need to press the backspace key because I need to now do the nested if part. Right now, we just have a dual alternative based on what we did prior. We get that. Now, a nested if is going to be the elif. All right. Else if, elif, all right, num1, okay, I'm sorry, num2, my bad, is greater than num3. So that's another scenario that may be the case. We just talked about that. Now we're supporting that third case, right? Else if num1 is greater than num3, again, we want to have our print statements kind of on the same indentation format. All right, if that's the case, num2 value is the biggest. All right, that would be true if that's the case. Else, and again, I warned you, these nested ifs are crazy bananas, right? Print, the only other possibility is num3 is the biggest, okay? That's a lot of code there, but we're going to check it logically. So when you type something, syntactically, it may be correct. Logically, it may be flawed. We're going to test our theory in a minute. So when everybody has gotten this typed, let me know, and we're going to walk through it. A lot of code there, right?
There's no G, it's 2 G's in the bottom.
Yeah.
Yeah, there's
And hers. Okay. Well,
I don't know if she did that on purpose or not.
Jack knows I do lots on purpose, right, Jack?
Okay, Just checking. Anybody need help?
Everybody's good?
Right.
While you have a minute, everybody refresh the page, my dashboard, my classes. See if you have the access. If you do not, you raise your hand and I come to you.
Everybody ready to execute their code?
Oh, I know. I think I know that one. Right here.
Anybody's code not work?
Yeah, everyone. No, we're. No, that's the one. Yeah. Oh, right.
Now, there's a reason why your code doesn't work. If your code looks like mine, don't get scared because there's a reason why it doesn't work. Okay? We're going to talk about it. I just want to make sure everybody creates the same syntax error. All right. And I did that on purpose. I wanted you to understand what a syntax error is versus semantics. Semantics is logic. Syntax is something is wrong programmatically. In other words, I did not speak to this correctly. And I have created an intentional flaw in our code. So this is a nested if statement, and it has very specific requirements. One requirement is that when you ask the first if, there has to be an alternative or a second if, I should say, not an alternative, but a nested if. And I don't have that in there. Okay. I jumped right here to this. Well, what happens is then this elif is not valid because elif is for the third time you ask for if. I only have two ifs here. In essence, I created a very sloppy dual alternative if that was supposed to be a nested if, which is three possibilities. So what I'm going to do is after my first if statement, if num1 is greater than num2, I need to then ask a second if. All right. If num1 is greater than num3 colon, and then what do I have to do? I have to indent this. Okay. So that's the first part of our problem. All right. And again, we're purposely doing this so that we can figure out, well, what is a syntax error? What is a semantic error? What is the difference between them? We're purposely making a mess because I want you to learn. All right. So I fixed the code and I got it almost there, but it's still not correct. And there's a reason why. Remember, I told you before about indentation. Guess what this else belongs to? This else belongs to the nested if. And this print statement needs to be indented. Remember, I told you Python is super fussy about indentation? Okay, that's why it's yelling at me. But notice the syntax error, it says, hey, it's invalid. We're not going to tell you what it is. We're going to say it's on line 13. But the problem wasn't on line 13. It was everything prior to line 13. So there's our dependency because we messed up the sequence of code, right? We created a problem where it can't run properly. All right, now it runs properly. Right? So I fixed the missing code, which caused the syntax error. I fixed the indentation problem. And now my code is executed completely. Now, all we know is that there are no more syntax errors. It may still semantically be flawed. We now need to look at it and check it for semantics. Okay. Everyone ready to do that? Let me know when everybody's ready. It looks like some folks are getting some help there.
Oh.
I think this is awesome. You guys are all in the class. It's so cool to see a full classroom. I love it. I love it. Everyone good? All right. So let's check it for semantics, logic, right? So num1 is 1500, num2 is 2500, num3 is 1000. So if we just eyeball it, we say, hey, num2 is greater than all of them. Num2 is greater than num1. Num2 is greater than num3. So we get that. So let's test the first thing. If num1 is greater than num2, then if num1 is greater than num3, which is what? Is it true or false? This statement here. Whoops, sorry about that. This statement here. Is num1 greater than num3? Yeah, right? So basically, if we stop there, num1 would be the biggest, right? But we added an else. So we added an else, which says, else if num1 is not greater than num3, or if let's say it's less than num3, num3 is the biggest. So is this part of the code right here, is this, when it ran this, is any of that applicable? In other words, would we expect that to be true? Is num1 greater than num3? Yes, right? If num1 is greater than 3, then the else is not going to be relevant. Okay. So right now, this if statement basically is saying, yes, that's true. So what's going to happen after that is what? It's going to look at a second question. Is num2 greater than num3? Is that true? Yes, right? 2500 is greater than 1000. So num2 is the biggest because it is true. Now, because this is true, this else statement, and it's typo that I have here, good Lord, is false, right? Because 1000 is actually the smallest. So does everyone understand how they got the result they did? Num2 value is the biggest. So when you get a result, you don't want to take it for granted that it's always accurate, that it's always true. You question every result you get. Whether you're a data scientist, programmer, what have you, you have to question the result and say, is it valid? Did we in fact test the logic and is it valid? Okay. So does everyone understand this logic? You're going to be recreating this for homework, by the way. Okay. Yes, Walker. Go ahead.
Hi, so line 8, if number 1 is greater than number 2,
Number 3. Oh, line 8. I'm sorry. Yep. Go ahead.
so that is false.
Number
Number
one
one
is,
is not.
that's correct.
So then that brings you to the next if.
Yes. Yep.
What if that were true?
Well,
Right.
if that were true, try flipping it around. So change your operator and see what happens.
Oh,
Yep. Just, and again, that's great that you're asking those questions. What if this is the case? Always question your logic. So go ahead and check it.
you mean change line, like make.
Line 8. So you want to make this less than, right?
Oh, okay.
Yeah, right. Aha. We've changed the result entirely, right?
Let's see. Number 1 value is the biggest. Okay, I'm just trying to follow. You go from that line to the next line
Mm-hmm.
to the else if line.
Right. Now notice, and I'm so glad you're asking these questions, Walker. So notice that, did this code run that I have highlighted there?
No.
No.
Right. And why is that? A nested if statement is designed to stop execution once it has what?
Like
A true.
A true. Okay.
You got it. You got it. So what's nice, it's a way of being efficient. Why execute code that's not necessary? Once we have a true condition in a nested if, end of execution, right? Because we have a true, done. We exit out, we're done. Okay. So that's just something to think about. Nested ifs have a very specific purpose. And if you want to short circuit, what's called short circuiting, you would design it in such a way that you only execute the rest of the code if in fact you have to look at other possibilities, right? And in some very complex programs or applications, there's some very complex possibilities, okay? So one of the things I want to encourage all of you, and again, I'm going to provide these code examples in OpenHub for you to work with homework, is to play around with changing these operands, the greater than's, the less than signs, and see the result and make sure you understand why, okay? Very, very important. All right, so that's our first example. That's the nested if. I'm going to send this little guy back to where he was, make him greater than, execute him. All right, now, because you have a smaller screen, I'm going to go ahead and delete this code and I'm going to go to the next one. You can leave yours on the screen if you want, because I want to actually build the third one, which is, or actually the fourth one, because we're still working with selections here. I'm going to do an if, it's called an if elif else. My gosh, if elif else, okay? So this is another example. Now, this example is basically going to look at an alternate if with an else as a third possible value. So it's not nested, all right, but it is like nested. And you're going to see the difference in a second here. So we've got our comment. We're going to declare our variables. Num1 is equal to 1500. Num2 is equal to 2500. All right. And then we ask a question. Again, this is our selection statement. If num1 is equal to, and that's 2 equal signs, num2, colon. So, and let me put a space here so you can see that. There's equivalence and being equal, equality. They are two different things, okay? So if num1 is equal to num2, we want to print. Again, here's our print command. We're using it like crazy, but that's how we're getting our output, right? Both values are equal to each other. All right. Remember, we talked about the equal to 75. We said we can't support that, but the application doesn't support it. Now we're looking at how do we support equality, right? Elif. Okay. num1 greater than num2. Okay, again, have to have that colon, right? Then, right, print num1, whoops, get a quote in there, num1 value is greater than num2, right? And then the last thing is going to be an else. So else, this is the third possibility, all right, but not nested. Again, it'll drive you crazy, but when you look at the logic, look at the results, you'll get it, right? We're going to print num1 is, whoops, num1 is less than, because that's the only other possibility. You could say smaller or less than. I'll say smaller. I'll say smaller, right? Smaller than num2. Whoops, num2. Okay. So this is an if, elif, else. So let me move this little panel over here. Come on now, work with me. All right, there we go. And do it again. There we go. So num1 is smaller than num2. So is this correct? Is this logically correct? What do you think? It's a pretty easy deduction, right? Num1 is 1500, num2 is 2500. But let's see what happens when we make them equal. We change the value, make it equal. So num1, let's change the second one to be the same as, right? When we execute this based on our logic, we expect this to render a different result. And sure enough, it does. So now that's an example of how you would entertain the equality aspect if you wanted to, in fact, test that. In other words, two numbers, but three scenarios, three possibilities. One is greater than the other, one is less than the other, or they are equal to each other. And that's how you would test for that equality. Okay, and that is done with an elif else. Now we do it this way because we need to look at all three possibilities, because all three possibilities are possible. Now I'm going to ask a question. Why did we test the equality first? What do you think? Does it matter? Now, anyone who knows me and how I teach, I always ask questions that I want you to scratch your head on. So why would we test equality first and then greater than or equal to?
If you answer that one, you answer the other two.
Say that, I'm sorry, say it a little louder.
If your answer is that they're equal to each other, then you know that they're not greater or lesser than.
Bingo, right, right. So again, this whole idea fits the principle of, you know what, if they're equal, let's just end it there, right? Call it a day. We don't need to check for greater than or less than. So think about it this way. Equal is one scenario. And if it's equal, we don't need to test the other two, right? But let's say we don't test equality first. Then we have to do greater than, then we have to do less than, and then equal as being the else. So it's actually more efficient to do it this way. So that is another trick to just think about. It's one thing to type the code and test all possibilities, but what is the best way based on what you know about what we're trying to do, the context of what we're trying to do? What is the best, most efficient way to do this? All right. And that's something to think about. That's something to think about. All right. Are you ready? We're going to do another. We're going to actually do repetition now. All right. So I'm going to delete this because, hey, you'll have it up on OpenHub. And now we're going to go to our repetition. Now, this is where it gets fun. Loops are cool until they break. And then they're not so fun, right? But loops are cool. All right. So we are going to call this for loop example number 1, but we're going to do it differently. We're not going to comment it. We're going to use a print statement. All right. So this is our for loop example 1. Why not? Because we want to see in the output each example and be able to visually compare the output. So comments don't get executed. Comments are not in our output. When we're studying the results of this, we want to see the examples labeled so that we can digest. Okay, this is a for loop. This is the first example. All right, so we're printing out basically the statement. Now we're going to put a comment. We're going to talk about something called range, because when you're doing a for loop, you have a counted loop, which could be a range of numbers, right? So range is a built-in function, all right, that Python has, okay, whoops. Python has that basically returns a sequence. It says, this is a sequence, I'm returning it because you gave me that as input and I'm going to give you the values back. So it basically is a built-in function that returns, all right, a sequence or a list or whatever you want to call it. So I have to define my list. Let me move this guy over a little bit so you can see. All right, so my list. Notice I don't have any spaces, right? No spaces are allowed. My list is equal to, and I'm going to use square brackets to define my list. Let's make it 100, 200, 300. Why not? So I've defined my list. This is going to be my input. For any of you who thought it was, you are correct. You get the prize. Okay. So here I have a list and I want to iterate through the list so that I can render that list as output. All right. So what I want to do is I want to use my for loop. So I'm going to type for I in range. Okay. I in range. And I'm going to explain this code in a second. Given the length of my list, so given the length of my list, all right, again, these are in parentheses now, not square brackets. Okay, colon. Okay, I'm going to wait because you probably are typing. Print my list. So I want to output my list. Square bracket I. Again, I'm going to explain this, so don't freak out. It's interesting code. Yes, it is. All right, comma, end, because we have to end what we're doing, equals quote /n. Wow, that's a mouthful. All right. We created a list. We provided values. That's line 5. And then we said for I in range. Now everyone's probably wondering, what is I? Each item in our list has a secret number behind the scenes, keeping track of where that item is in the list. The first one is going to be 0. The next one's going to be 1. And the third one's going to be 2. It's an array. It's an array of values. So 100 has the placeholder behind the scenes of 0 as a subscript. It's saying, we know what 100 is, and it's always going to be 0 because of where it is in the list, in the series. It's first, and 0 is always first. 200 is second, so that's going to be 1. 300 is third, so that's going to be 2. Okay. So for I in range, for each item in the range, for I in range, for each item in the range, up to the length of my list. Okay, now I see I already have a typo here. This should be a lowercase l. So make sure these guys match. And these guys is 2 as well. What can I say? Sometimes eyesight, right? So for each item in the range is this list, up to the length of my list. So count everything, don't leave anything out. Print the value of that item based on where it is in the order in the list. That's print the list using I as an index. And at the end, wrap to a new line. That's what this means. /n is go to a new line. So let's try and run it. Boop. All right. And if anyone has problems, raise your hand so someone can help you. If yours did not run properly.
Everyone say no?
Everyone doing okay? Getting there? Now you're probably wondering, when are we going to analyze some data? Believe it or not, you have to know how to do this to be able to iterate through a spreadsheet of data or a data set, right? So these skills are very essential. And again, it's the Python syntax that you have to learn to be able to iterate through that list of data that you want to analyze.
Thank you.
Everyone say no?
While we're here, I'm just wondering, maybe 1 second break. Anyone
Yes, we can take a refreshment break. How long?
There are only 4 bathrooms total at the library.
Oi. Okay, so do you want to pause for 5 minutes, 10 minutes?
Yeah.
About it. Okay, let's start with 5.
Okay, we will pause for 5. I will refresh as well, and I will see you back in 5. I'll pause the recording.
And meanwhile, for all newcomers, make sure you have an account on Slack. Right?
Okay. All right. So during our break, Connor asked a great question on Slack, and I want to address it for everyone. Connor said, well, why are we using this end equals and then quote /n? And the reason for that is the print function by default typically will end with in other words, at the end of the output, whatever it is, it could be a message, it could be whatever, it automatically ends and goes to a new line. Okay, that's just the nature of the print function. Since we're reading data, all right, we want to force it to pass white space as the end so that the list item, and whenever the list item is done, it automatically signals that we go to a next line. Okay. Now, as Connor discovered, we don't have to put the end equals. It'll still work, but this guarantees that we get the result that we want. And oftentimes in coding, you'll find out that if you want to be 100% sure that something happens the way you want, you do it with extra code, which is what the end equals is. So thank you, Connor, for that question. That is awesome, awesome, awesome. And we are going to go to another example. Are you ready? Now, this one is going to be, well, it's going to be more comprehensive. Not scary, but comprehensive, okay? All right, so we did a for loop. Let's look at another type of for loop that uses range. I think hopefully everyone is getting what range does, okay? So before we do anything, let's print a divider line so that we can see the difference between all of our examples here. So I'm just gonna do a good old-fashioned print a line so I can see, where one example ends and the other begins, okay? And this one is going to have basically example 2. So this is going to use the, we're going to use range, but I want to talk about how range handles a list and how it loops through that list using for to count something, okay? So I'm going to put a note here, what I want you to understand and remember. So note that the maximum value, and remember, when we talk maximum, we're talking about numbers, right? The maximum value in a range is always n minus 1. The reason for this is the first value is set to 0. So we output 100, 200, 300, okay? That was not an issue. So in this example, the one that we did prior, the n minus 1 didn't really apply here. But what I'm about to show you is going to show how it is applicable. So we're going to say print example 2. All right, and this is our for loop example number 2. All right, because we want to differentiate between that one and the other one. And so we're going to do very much the same as before. For I in range, for I in range. And in this case, instead of a list or an array, I should say, we're going to do a range of values that we're going to feed it. So this is our input, 100, 200, and 200, and I. So that's our range. I know it looks strange. I'm going to explain it in a minute. I made a rhyme just now. So we got to put a colon at the end. And of course, we're going to print. So we indent. It automatically did it for us. Print I, end equals. Okay. And then we're going to do the same thing as before, the /n, which takes us to a new line. Okay. So at the very end, we actually want to /n. But end is white space. So, and it'll come to you. All right. So now we specify print I in, or for I in range. So if we have 100 and 200 and we're printing I, it's highly likely we're going to print all the values between 100 and 200, right? 100 and 200. That's what it looks like, just logically. So I'm going to go ahead and run this. Does everyone have this typed, hopefully? Yeah, okay, I'm going to go ahead and run this, and let me bring this over. And there is a syntax error. Who knows what the syntax error is? It's a really easy one, but who knows what I did wrong on line 9? I did a bad. What's that?
It's the quotation.
I heard quotations. Awesome. Someone gets the awesome prize, right? So notice it says, I can't work with that. Invalid syntax. I did not feed the proper command to the print command, or argument rather to the print command. So now I'm going to execute it and move this over. Okay. So here's something that's interesting. 100, 102, 104, 106. What's going on there? 108. Wow. It looks like we're skipping by 2. What do you think is going on? What do you think is causing that? What's that? One of the things I want you to do for homework is I want you to research the range function. And again, we're not going to do it now, but the range function is really powerful in Python. And you will use that to go through a variety of different data, you know, that you look at, whether it's an Excel spreadsheet, a SQL database, what have you. So for each value in the range between 100 and 200, what are we doing? We are incrementing by I. So it's an increment by 2. Interesting. Interesting. So we're printing I and we're incrementing. So one of the things you're going to do for homework and then bring it to office hours is tell the person you're working with why this works the way it does. This is a nice tricky one. And again, I'll be posting these up in OpenHub. Okay. Because it seems very interesting. It seems like, well, if I'm printing my list, and the list is arranged kind of like up here, why aren't they treated the same? Well, one is an array and the other is a list, but they're very much like each other. And I want you to tell the person you're working with, or you could even post it on Slack and say, I found the Easter egg, I found the answer. Why is this working the way it is? Now, when you do determine that, I want you to put a comment in your code that explains why your code is working the way it is. That way, when you go back and you look at it, or if you're talking with a colleague and you're working with them, you can say, hey, I found the answer. I know why it's working this way. And I put a note in my code. You want to see it? And then you're sharing your knowledge with other people. All right, so that's Easter egg number 1. Now I'm going to show you another trick. Since time is of the essence, I'm going to copy and paste number 9, line number 9, down to a lower line here. Okay, so that we don't have to type it. Now, let's look at a while loop. Now remember, counted loop is we're counting something. A while loop is different. So this is going to be a while loop example. So I'm going to print while loop, whoops, while loop example. I got to trim my nails so I don't make a mess on the keyboard. All right. Now, let me make sure this is all in the same line there, or indented. All right. So I'm going to initialize a variable called A equals 10. Can everyone still see, or do you want me to delete what's above here? Should I delete what's above? Get rid of this stuff?
Yeah.
Yeah, okay, I figured it might be easier. Okay, so A equals 10 and I equals 0. Okay, so we've defined two variables. We have basically, determined that there's a reason why I is 0. I'll tell you that reason in a second. You'll see it actually, you'll probably pick up on that. So I'm going to start a while loop. While, and here comes my Boolean expression, while I is less than A. All right, remember it's referring to the value and not the alpha letter, right? While I is less than A, colon, print, print I, right? And then comma, end equals, quote, space, quote. And let me get a good space in there so you can see it. All right. Now you'll see what this looks like in a minute. Now, the next thing we need to do is I is equal to I plus 1. So we're saying take the value of I and add 1 to it, increment by 1. All right. And then do another print statement. And we'll look at the logic in a second. And we're just basically going to do a quote. We want a slash n. All right. The reason for the slash n is new line. And then put the words end of loop. This just tells us our loop is ended. We're on a new line because we're past the loop. We're after the loop. It's completed. Okay. So while I is less than A, that's our Boolean expression. All right. I less than A. While that's the case, print I white space and quote, quote, meaning dead white space, right? It's just some spaces. All right. And then increment I, take I and kick it up a notch. So if it was 1, it goes to 2. If it was 2, it goes to 3. Increase the count, as it were, or increment rather than decrement. So let's run this and let's see what it looks like. And let's move this little guy over. Come on, you. There we go. So interesting. Notice it didn't go to a new line. It used white space and only white space. Okay. And what did it do? Well, it put a space in between the 0 and the 1. That's this right here. So rather than go to a new line, give me an extra space between the values. Okay. Remember, the print function wants to go to a new line. That's how it's written. That's how it's ingrained. It's born to do that. Go to a new line. And we're saying no, end it by iterating, giving us a space in between the values. Don't go to a new line. And while you're at it, increment. Okay. So while I is less than, which basically while 0 is less than 10, while that's the case, increment. And of course, output. So we start with 0, we end with 9. So that's kind of odd, isn't it? Right? Why do you think that is? Why did we start with 0? What's in the 0 placeholder? The first placeholder, what value? It's I, right? And it's I subscript 0. What's the value, the actual number?
1.
Actually, it's 0. So remember, the first time you iterate, I is going to be 0. So you start with the value of I because we said print I, right? So the first thing it's going to print is the default value. That's its starting point. Then it's going to increment by 1. So then the next guy is going to be a 1. And then it's going to increment by 1. And it's going to keep doing that until it gets to the end. Now, why did it stop at 9? Who knows why it stopped at 9? what did our Boolean condition or test? What did our Boolean expression test?
I less than A.
It's less than A, and A is 10, therefore we stop at 9. Awesome. You see how that works? So that's a while loop. And it's saying, while this is true, print out, this thing or do some task, right? So here's what's interesting. Yes, we have numbers involved here, but this is not a counted loop. Even though it involves numbers, the for loop is a counted loop. It says, do it a specific number of times. This is saying while something is true, meaning our comparison, right? I less than A, right? We're comparing 0 and 10. While that's true, print I and the value, and then a space, and then go to the next one, the next one. While this is true, keep looping, right? There is such a thing called an endless loop, though. If your logic is flawed, and let's say it does not know how to loop and end, it will keep going, and that could actually break your system. So what you want to remember is that you need a loop control variable. Okay, your loop control variable is this right here. All right, I equals I plus 1. I is your loop control variable. It will iterate while I is less than A. So if it does not know I, if let's say you didn't have a declaration of what I was, it would be an endless loop. It wouldn't know. It would say, what's I? I'm going to loop, but I'm going to go crazy and I'm going to go off the rails because you haven't told me to control my loop with a loop control variable. You haven't fed me the information I need to stop my loop. And that's a bad thing. What that means is then your application keeps spinning. I don't know if anyone has ever used an app that just keeps going and going. That's like an endless loop or like a memory hole, or it's basically the program has no way of controlling itself. So you want to always make sure you test your code, make sure it's working as expected. Go back and test different scenarios to make sure it doesn't blow up on you, and always make sure that the logic is correct. Now, based on what we intended for the output is correct. All right. So that's something to think about. Let's do one more. All right, let's do one more. So again, I'm going to cheat here. I'm going to grab this print line here. And actually, I'm going to grab both of these. All right, and plop them here. This is example number 2, by the way, that we're doing. This one was example number 1. Again, I'll provide these on OpenHub for you. So let's do a different one. Let's declare I equal to 1. All right, so we're giving it a value, which is super, super important. Let me back this up for you. All right, I is equal to 1. While I, now you're going to like this one, while I is less than or equal to 10, all right, and let me put a space here so you can see it. All right, while that's the case, we want to print the squares of all the integers in that range of values. So we're going to print the square values of all integers from 1 to 10. Okay, let me move this over. Okay. All right, 1 to 10. Boop. Okay. All right, so while I is less than or equal to 10, print, and you're going to love this. You'll get used to these operands. I, and this is asterisk asterisk. It's shift 8, 2. That's the square root, or I'm sorry, square value, not the square root, square value. All right, print I and the square value, to the, basically to the square value of whatever I is. And then I is going to be plus equals 1. So what this means is I is going to be equal to the value of I during that iteration plus 1. So it's basically an assignment of itself plus 1, itself plus 1. Okay. This is, again, another while loop that's going to square the values of all integers from 1 to 10. Now, if I starts at 1 and less than or equal to 10 is 10, we should get everything between 1 and 10, right? Probably, right? Let's test the theory. Let's see. Ah, let's move this puppy over here. Come on now. My trackball mouse has got a mind of its own. So is it correct? Well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so it goes. And the last value, 10 times 10 is 100. So there you have it. So that's an example of a while loop. Again, it's using the Boolean condition I less than equal to 10. That's the Boolean condition that's being tested. And again, you can thank George Boole for all of his goodness. You can do research on George Boole. He's the guy, he's the man. He drives the logical expression bus. So we tested the logic. While that's true, do something. Print I and the square root of I, right? Or the square of I. I keep saying root, forgive me. Square of I. So 1 times 1, 2 times 2, 3 times 3, so on and so forth. Take the value and square it. Pretty cool, right? Anyone lost? Everyone caught up? Getting there?
Can you explain on line 19?
Line 19, yes. So I is equal to 1 plus I. So it begs the question, is it the same as line 9? What do you think? I is equal to I plus 1. Do you think these are the same?
Yes.
Yes.
Okay, should we test the theory? Let's test this. So we're going to comment this out, and I want to show you guys a trick. Let's say you're wondering, well, why does this code work the way it does? I'm going to copy and paste this guy down below and execute this instead of the one that I had and see, do I get the same result? Is anyone spinning? Ah, what do you think is happening? Is everyone disconnected from the server?
The internet says there's an error connecting to the server.
Yeah. So, case in point, let's refresh our screen. And if you lose your changes, don't worry. I will have mine. As a matter of fact, let me cancel. Let me just copy this to the clipboard before I refresh. All right. Here we go. Let's get rid of it. And I'm going to refresh the screen. Yes, reload, please. We made the server very mad. Very mad. We were bad. So let's get rid of the bad code. Let's uncomment the good code and see if it runs. Ah. So guess what? It had nothing to do with our code. Okay. And someone I think mentioned the server, right? So
Yeah,
it looks like, what's that?
There's an error while connecting to the server.
To the server, right?
Yes.
Yeah. So what this means is their website is having a problem. So this has nothing to do with us or what have you. So here's what I want you to do for homework. Yeah, we broke their website. You guys are testing the theory. Is the website strong enough for an intro to data analytics class? Fail, hashtag fail, right? But these things happen, right? These things happen. It could be a storm. It could be anything, right? Or maybe we were the storm. All right. So let's wrap up. And what we want to do is I'm going to stop sharing my screen. I'm going to stop sharing my screen. So what I'm going to do, just to wrap up, I will be uploading all the code to OpenHub, so you'll be able to download it and play around with it. Keep in mind, there'll be text files, so you'll just copy and paste the code into the compiler. I do encourage you to do that. I encourage you to change the values, make them different, see how it responds differently. And I encourage you to have an open dialogue with either the office hours person or your friend next to you that you want to code with. Remember, paired programming is a great way to learn from each other and observe different things that you see. Just to recap what we talked about tonight, we talked about the control structures, the classic 3, the selection, sorry, the sequence selection and repetition. And those in combination is what you use to develop the logic for programs that you want to design. So this week was rather light, but maybe not so much. I want you to practice, because as you start practicing, you start seeing things. So for homework, you want to make sure you get a Google account. If you don't already have one, you want to click on the link in OpenHub where it says Intro to Colab. You want to just look at it, read the material that are there. Next week, we're going to be using a different online compiler, one that is more robust and designed for data scientists, okay? This was basically a practice tutorial site, so we broke it because we're good. We'll go into one that's more robust, and we'll be practicing with that and get you familiar with Colab. Now, the rest of the class will be done in Colab. Colaboratory is created by Google. It's a research project, but basically they have a lot more horsepower. They have a lot more resources dedicated to it. And if you're really inclined, you could actually pay to get more GPUs, so you have all the horsepower. Haha. All right, all the goodies. So any questions that I can answer before we wrap up? I hope you've enjoyed this. Any questions? You're welcome. Anybody recognize what's on the back of my screen? Binary. Excellent. I did that on purpose. Now, the question is, what does it say? Oh, what does it say? It's probably a secret message. You know, I don't know. I just grabbed it from the internet, but you know, hopefully it's, you know, hopefully it's a nice message and I'm not swearing at you or something, you know, but that's binary. How cool is that, right? So thank you, folks. Thank you so much. Make sure you reach out on Slack. Slack is a great resource. We're on there all day long. We can help you with questions that you have. Reach out to your support people. There's a lot of support for this program, so take advantage of it, all right?
Thank you.
You're welcome. You're welcome. Awesome. Awesome. I'm going to stop the recording.
So Saturdays, 12:30.